The race to build the world's fastest supercomputer. Hello everyone, and welcome to this exciting video on the race to build the world's fastest supercomputer. In this video, we'll explore the world of high-performance computing and discover how researchers are pushing the boundaries of what's possible in terms of computing power. So, let's dive right in. 1. The history of supercomputing. First, let's take a look at the history of supercomputing. The first supercomputer was built in the 1960s, and since then, there has been a constant race to build faster and more powerful machines. We'll explore some of the key milestones in the history of supercomputing, from the Cray 1 to the present day. The Cray 1, designed by Seymour Cray in the early 1970s, was a landmark in the history of supercomputing. It was the first machine to use vector processing, which allowed it to perform calculations much more quickly than traditional computers. The Cray 1 had a peak performance of around 250 megaflops, million floating point operations per second, which was a significant improvement over previous machines. In the 1980s and 1990s, supercomputing saw a major shift towards massively parallel processing. Instead of relying on a single processor, these machines used hundreds or even thousands of processors working together to perform calculations. This allowed for even faster processing speeds, and led to the development of some of the most powerful machines in history, such as the thinking machines CM5 and the IBM Blue Gene. In recent years, supercomputing has continued to push the boundaries of what's possible in terms of computing power. In 2018, the Summit supercomputer at Oak Ridge National Laboratory became the first machine to break the exaflop barrier, achieving a peak performance of 200 petaflops, quadrillion floating point operations per second. With each new breakthrough, researchers are able to tackle increasingly complex problems and make new discoveries in science and engineering. 2. The challenges of building a faster computer. Building a faster computer is no easy task. There are many challenges involved, from designing more efficient processors to finding ways to cool the machine. We'll explore some of these challenges and see how researchers are overcoming them to build the fastest supercomputers in the world. One of the biggest challenges in building a faster computer is power consumption. As processors become more powerful, they require more energy to operate, which can lead to issues with heat dissipation and power supply. Researchers are constantly working on ways to make processors more energy efficient, through techniques such as reducing the voltage required to run the chip, optimizing the layout of the circuitry, and using new materials like graphene. Another challenge in building a faster computer is the issue of memory bandwidth. As processors become faster, they require data to be fed to them at an ever-increasing rate. This can cause a bottleneck in the system, as the memory cannot provide data fast enough to keep up with the processor. To overcome this challenge, researchers are exploring new memory technologies, such as 3D stacked memory in high bandwidth memory, HBM, which can provide much higher bandwidth than traditional memory modules. Finally, another challenge in building a faster computer is the issue of software optimization. Even with the fastest processors and memory, a computer can only perform as quickly as the software running on it. To fully exploit the power of a supercomputer, software needs to be designed to take advantage of the parallel processing capabilities of the machine. This can be a complex task, as it requires a deep understanding of both the hardware and the application being run. Researchers are working on developing new programming models and algorithms to help optimize software for supercomputing environments. 3. Applications of supercomputing. Supercomputers are used in a wide range of fields, from weather forecasting to drug discovery. We'll explore some of the key applications of supercomputing and see how these machines are helping researchers make breakthroughs in science and engineering. One of the most important applications of supercomputing is in the field of scientific research. Supercomputers can be used to model complex physical systems, such as climate patterns, the behavior of proteins and molecules, and the dynamics of galaxies. These simulations can provide valuable insights into how these systems work and help researchers make predictions about how they might behave in the future. Supercomputers have been used to make significant contributions in areas such as climate science, astrophysics, and materials science. Another important application of supercomputing is in the field of medical research. Supercomputers can be used to model the behavior of biological systems, such as cells and organs, and to simulate the effects of drugs on these systems. This can help researchers develop new treatments for diseases and test them in a virtual environment before moving to human trials. Supercomputers have been used in the development of new cancer therapies, in the study of genetic diseases, and in the design of new drugs to combat infectious diseases. Finally, supercomputers are also used in industry and commerce. They can be used to simulate manufacturing processes, optimize supply chains, and design new products. Supercomputers are also used in finance, where they can be used to analyze large amounts of financial data and make predictions about market trends. Supercomputers have been used in the development of new materials, in the design of new aircraft and automobiles, and in the optimization of energy systems. 4. The future of supercomputing. Finally, we'll take a look at the future of supercomputing. We'll explore some of the exciting developments that are on the horizon, from quantum computing to exascale computing. We'll also discuss how these developments could impact society and change the way we live and work. One of the most exciting developments in the field of supercomputing is the emergence of quantum computing. Unlike traditional computers, which use bits to represent information, quantum computers use qubits, which can represent multiple states at once. This allows quantum computers to perform certain types of calculations much more quickly than traditional computers. While quantum computers are still in the early stages of development, researchers believe that they could revolutionize fields such as cryptography, materials science, and drug discovery. Another major development in the field of supercomputing is the move towards exascale computing. Exascale computing refers to machines that can perform a quintillion, 10 to the power of 18, calculations per second. These machines will be capable of processing massive amounts of data and running complex simulations in real time. Researchers believe that exascale computing could have a major impact in fields such as climate modeling, energy production, and national security. Finally, as supercomputers become more powerful and ubiquitous, they could have a major impact on society as a whole. For example, supercomputers could be used to develop new sustainable energy sources, to improve healthcare outcomes, and to enhance education and learning. They could also be used to analyze social media data and predict trends in public opinion, which could have implications for politics and democracy. As we continue to push the boundaries of what's possible in terms of computing power, we are likely to see even more exciting developments in the field of supercomputing in the years and decades to come. Well, that's it for today's video on the race to build the world's fastest supercomputer. I hope you enjoyed it and learned something new about the fascinating world of high-performance computing. As we've seen today, the race to build the world's fastest supercomputer is an ongoing competition that has been going on for decades. While the history of supercomputing is filled with fascinating developments and milestones, it's clear that we are only scratching the surface of what's possible. As researchers continue to push the boundaries of what's possible in terms of computing power, we are likely to see even more exciting developments in the years and decades to come. One thing is certain. Supercomputers will play an increasingly important role in our lives as we move towards a more data-driven, technology-driven world. From scientific research to industry and commerce, supercomputers will continue to be at the forefront of innovation and discovery. And as we continue to make breakthroughs in the field of computing, we will undoubtedly find new and exciting ways to use these machines to improve our world and our lives. So, thanks again for tuning in today, and we hope you'll join us for more great content in the future. In the meantime, feel free to leave a comment below with your thoughts on supercomputing and where you think the field is headed. We always love hearing from our viewers, and we can't wait to see what you have to say.